Lesson 3 on a volume and surface area of 3D shapes. So we're going to first start talking about prisms, and in prisms we're going to be looking at the area in terms of volume. It's going to be the area of the base, and that area of the base is going to be the shape that gets stretched. So when they talk about the base, it's the shape that gets stretched, and we can see that most for the triangular prism. So it's the shape that gets stretched. A fancier word is extruded, if you know that word. And then it's going to be times the height. And by height, it doesn't necessarily mean how tall something is. It means how long that base shape is extruded or stretched. So height here is how far the base is stretched or extruded. So that's for finding the volume of a prism. And if we look at the triangular prism, its base is the triangle. So look down at the bottom of the screen. The base is the triangle, and then it is extruded that length h. But if it was a tent, then and it was lying on its ground, it would still have the triangle would be the base, but then what we would maybe call the length is actually how long that triangle is extruded. Surface area, we just have to be careful about making sure we get all the sides. And for a cylinder, if we're doing the surface area of cylinder, we have to be careful to check if it has a top or bottom. And so in this case, I'm going to write down what the surface area of this one would be. The total surface area, if it does have a top and a bottom, it's going to have 2 times pi r squared, because it'd have 2 circles. And then in this diagram here, that in the net is really all the way around that circle, and we know that the circumference is 2 pi r, so that means that's 2 pi r. And then in the unfolded one, this is h, so that means this is h. So for surface area, I've got the two circles, plus the area of that rectangle would be 2 pi r times h. If there was no top, then it would be only going to be, so S area of no top would just be 1 pi r squared, and we wouldn't even have to write that 1 plus the 2 pi r h. And if there was no top and no bottom, SA, so like open, no top, no bottom, then we wouldn't have any circles at all. It'd just be that 2 pi r h. When it comes to looking at the volume of pyramids, we're going to take the area of the base, times it by the height, and divide it by 3. It's always going to be that divided by 3 thing when we have a pyramid. And surface area, again, we're going to have to be careful with all the nets. And we're also going to have to be careful that when we're talking about pyramids, we're using the slant height. So that would be, which one would be easiest to show you on? For the square base pyramid, if I want the surface area of the triangle, I'd want that height, and that's often used with a letter S for the slant height, as opposed to the height of this actual pyramid, which would go from the top straight down till it hit the midpoint of the base, and that would be at a right angle. The slant height is at a right angle on the surface. So in this diagram here, your slant height would be that height in those boxes. For a cone, if we have a height, I'm going to do the height in blue. If we have the height here of this cone, That would be the height at a right angle. But then there would also be the slant height on the side. And the total area here, the surface area, is pi r squared plus pi rs, where that s here, the s equals the slant height. And then there's the volume and surface area of a sphere. So now we're actually going to start some of the examples. In example 1, we need to find the volume and the surface area for all these things. I've written out some of the formulas already and done some coloring. Volume of a box is the easiest. It's just length times width times height. So in this case, it's going to be 11 times 12 times 13, and the order doesn't matter because we're multiplying, and when we multiply that all together we get 1716. In this case it's centimeters cubed, and we don't forget our units. So the volume is 1716 centimeters cubed. Now the surface area, if you try to visualize a box, it's got 6 sides. It's got the top and the bottom, but they're going to be the same size, so I'm just going to be 2 times the top. It's got the front and the back. Those are the ones I colored blue. And those are going to be the same size. And then the 2 sides are also going to be the same size. So when we do this, it's going to be 2 times the top is going to be the same as the bottom, so that's going to be 12 times 11. And then the front is the blue, so that's going to be 12 times 13. And then the sides are the pink, so 2 times 11 times 13. So that's 2 times 132, which is 264, plus 2 times 156, which is 312, plus 2 times 11 times 13 is 143, and that works out to 286. So when you add that all together, I got 862 centimeters squared, because surface area is always centimeters squared. That's example 1. For example 2, we got to find the volume and the surface area of this extruded or stretched circle base. So with a circle base, it's going to be, the volume is going to be pi r squared times how tall it got stretched, or that h. Pi, 3.14, radius, 6, squared means we write it out twice, and then times the height is 10. Put that all in our calculator, and I got 1130.4 centimeters cubed. And for the surface area, this is a solid cylinder. We can tell because the whole thing's kind of shaded. And for a solid cylinder, that means we're going to include the top and the bottom. So we're going to have 2 pi r squareds, because those 2 circles. And then we're going to have that whole side area that when we unwrap it turns into a rectangle. And that rectangle is going to be this part here. And if we sub in our values, we're going to have 2 times 3.14 times the radius is 6 squared, so I write it out twice, plus 2 times 3.14 times the radius is 6 times the height is 10. When I did this, I got 226.08 plus 376.8. Add those together and I got 602.88. And because it's surface area, my units are going to be centimeters squared. So 602.88 centimeters squared. Question 3 is dealing with a sphere. They give us the radius. The only way to make this one trickier would be to give you diameter, but they didn't, so it's going to be 4/3 times 3.14 times radius cubed, mean it's going to be 10 times 10 times 10. And when I did that on my calculator, I got 4,442.9 centimeters cubed. 4,442.9 centimeters cubed. For the surface area, It's 4 pi r squared, which is pretty easy. So it's going to be 4 times 3.14 times 10 times 10. Oh, I've made a mistake. I was using old numbers. But this is going to be 4 divided by 3 times 3.14 times 10 times 10 times 10. Apologies. I was going off old numbers. So this one, the volume is actually going to be 4186.7. 4186.7. And then the surface area is going to be 4 times 3.14 times 10 times 10. And I got times 10 times 10. So I got 1256 centimeters squared. 1256 centimeters squared. Question 4. In question 4, they want the volume and the surface area of a triangular prism, but it's on its side. It's not stretching vertically. So when we know that the volume is going to be area of the base times the height that it gets stretched, remember that height is the height it gets stretched. So this height is the height it gets, and I'm going to put stretched in quotes. The height it gets stretched is on this picture is the 20. So that height is going to be 20 meters that it got stretched. I also need to figure out the area of the base. So that's going to be the area of the triangle. And in this case, the base is going to be 8.5. The height of the triangle, sorry, the base of the triangle was 10. The height of the triangle is 8.5 divided by 2. And that is 42.5. So the volume of this is going to be 42.5 times the height, which is 20, and that gives 850 meters cubed. So the volume is 850 meters cubed. Now for the surface area, we got to stop and think. If we were to undo all the sides on this, we're going to have a triangle at the front and the back, and they're going to be the same shape. So we're going to have 2 times that yellow triangle. We're going to have the base, and then we're going to have the 2 slanty sides. Those are the ones that I highlighted in blue. So let's go through each one of these. We know that the area of the triangle is going to be 42.5 because we already figured it out. It was the green one right there. That was the area of the triangle. Now the area of the base I'm going to outline in black. The base would be that one. So it's a rectangle that is 10 times 20 big. And then for each of those blue sides, they're also rectangles, and I've got 2 of them, and each one of the blue ones is going to also be 10 times 20, but that won't always be the case. It just happens to be the case now. So that would give us 85 plus 200 plus 2 times 200. So that's going to be 85 plus 200 plus 400, and add those all up, and we get 685. Surface area is in meters squared. So that's the answer for question 4. Question 5, we have our first cone. So in question 5, for the volume, we're going to want the area of the base, which is a circle, so pi r squared, times the height of it divided by 3. Now the height of it, they didn't tell us, but we're going to use Pythagorean theorem to figure it out. So the height squared plus 6 squared, because it's a right triangle, is going to equal 10 squared. So that means h squared is going to equal to 100 minus 36. H squared is going to equal to 64. Square root both sides, and we get that the height is 8 centimeters. So we're going to use that, and it's going to be 3.14 times a radius of 6 squared, so write it out twice, times the height is 8. This whole mess divided by 3. I got that the volume was 3011.44 centimeters cubed. 301.44 centimeters cubed. And for the surface area of the cone says we're going to do pi r squared, that's the circle on the bottom, and then the last part is going to be plus pi times the radius times s, which is the slant height, and in this case they told us the slant height was 10. So it's 3.14 times 6 times 6. That's our first part. I got 113.04 plus 3.14 times 6 times 10. And for that, I got 188.4. Add it all together, I got 301.44, and surface area is in centimeters squared. Oh, and it's just totally a coincidence that the volume and the surface area work out to be the same. Okay, question 5 done. Question 6. Question 6 says it wants the volume and surface area of this square-based pyramid. There's not a ton of room, and they gave us a hint that we must find the height of the square-based pyramid. So I drew that in pink. The height of that square-based pyramid would go from the top down to the bottom of the pyramid, and I made a right triangle. If it's 6 all the way across, then it's only going to be 3 on the bottom of that pink triangle, and we know that the slant is 5. So if we calculate, h squared is going to equal 5 squared, 25, minus 3 squared, which is 9. So h squared equals 16, square root both sides. We get that the height is going to be 4 meters. So height is 4. We know that that height is 4. Okay. We got the height of the pyramid. The volume of this combo shape, though, is going to be the volume of the box. Boxes are easy. That's going to be length times width times height. In this case, that would be 2 times 6 times 6. 36 times 2 is 72. Plus, I'm going to have to write really small, or I'm going to write over here for the area of the base. Area of the base is still that square, 6 times 6, times how tall it is. Well, we just figured that out. That was 4 divided by 3. And 6 times 6 times 4 divided by 3, when I do that, I got 48. And when I add those all together, I got 120 meters cubed. For the surface area, we're going to have the 4 triangles that make up the pyramid, and then we're going to have the base. And because it's a square, we're going to have 4 times whatever those sides are. And the sides, if I was to color them in, let me use a different color than yellow. The side, I would have 4 of this shape. And all of them are going to be equal because it's a square base. So when we're figuring out the surface area here, for each one of my triangles, if I were to draw it out, the height is 5. It's that height there, and the base is 6. So the area of a triangle is going to be base times height, 6 times 5, divided by 2. So 30 divided by 2 is 15. So for the surface area of my whole shape, I have 4 times 15, which is 60, plus the area of the base, which was 6 times 6, or 36, plus 4 times the sides, so 4 times 2 times 6, which is 4 times 12, which is 48. When I add those all together, I get 144 meters squared. Last question. The last question asks us to find the surface area only of this step. 3-dimensional step staircase thing. So if we're looking at surface area, we're going to have 2 of the side shapes. If I were to shade that in, it would be this blue part. And then we're going to add on a whole bunch of what I think of as the edges. So we'd have this edge and that edge and this edge and that edge and this edge and that edge. I'm going to zoom in on this because I'm going to label those. I'm going to label them 1, edge 2, edge 3, edge 4, edge 5, edge 6. But then we're going to have two edges that we can't really see right now. There's going to be the edge that goes all the way down the back. I'm going to call that edge 7. And then we're also going to have the edge that it's sitting on, the bottom edge. So I'm going to call that edge 8. So if we're finding the surface area, we want to have it for 2 of the staircase shapes and 8 of the edges. To find the staircase shape, I drew it again down here with all the edges that I know. So, and I broke it into 3 different rectangles. So this first rectangle here, that would have a height of 15 and a width of 3, so that's going to equal 45. For the second one, so let's write that down. 2 times, it's going to be 45 plus something else. For the second one, this height, we don't know what it is, but we can figure it out. If the whole thing is 15, then this height here is going to be 15 minus 6, so that's going to be 11. So that shape here is going to be 5 times 11, or 55. I subtracted wrong. 15 subtracting 6 from 15 gives us 9. So that would be a height of 9, and that would give us then that this area is 45. So we'd add that in this shape, total shape. And then this part that's left, I've used up 3 and 5 out of 12. So 8 out of 12 leaves me with 4 left. And then in terms of the vertical, used up 6 and 4 is 10, so that would leave me a height of 5. So for this last shape, it's going to be 4 times 5, which is 20. So for that surface area, it's going to be 2 times 45 plus 20, which is 90 plus 20, so that's 110. So that the 2 side shapes altogether is going to give me 220. And now I'm going to have to add all the 8 edges. And I know it's annoying and it's long, but it's not that difficult. All of these guys have a width of 2. So it's just going to be about figuring out what their shapes are. So for shape 1, we already figured out down in the bottom diagram, we figured out that the height of that shape was 5. So for shape 1, it's going to be 5 times 2, which is 10. For shape 2, it's we also figured out how big that part was, and we figured out it was 4. So that's going to be 4 times 2, which is 8. For shape 3, they straight up tell us it's 4, so another 4 times 2, which is 8. Shape 4 is 5 times 2, which is 10. Shape 5 is 6 times 2, which is 12. Shape 6 is up at the very top there. That's 3 times 2, which is another 6. Shape 7 is the big tall one. It's 15 times 2, which is 30. And shape 8 is the bottom one it's sitting on, so it's going to be 12 times 2, which is 24. And when I added all of those up, I got 108. So for the surface area, we're going to have to add that 108, and I get 328 units or centimeters squared. Which is different from the bottom, but I'm pretty sure I'm right. Thanks for watching.